Hello Year 2 and welcome to your final lesson on fractions, as next week we will be beginning a new topic. I've been so impressed, and I've spoken to Miss Head and I've spoken to Miss Baldwin about your learning that we've been seeing on Seesaw. Your understanding of fractions has really come on, so absolutely fantastic work. I think everyone gets a dojo, to be honest. I've been so impressed. Your understanding that a fraction is part of a whole, because all it is a fraction is part of a whole. So, as I said, today is our final lesson. We're going to start with a little bit of a do now. So get your pen and your paper ready. And can you answer these three questions? Let me share my screen. I would like you to pause the video and answer these three questions. Pause the video. Off you go. Well done. Let's have a look if you were right. So what fraction of this star has been shaded? Well, I'm going to write the denominator first, and the bottom number, the denominator, tells me how many equal parts I have. I have 1, 2, 3, 4, 5 equal parts. So my denominator underneath my vinculum will be 5. How many have been shaded in? Because that will tell me my numerator, my top number, 1, 2. Therefore, 2/5 of the shape has been shaded in. The whole shape has not been shaded in. 2/5 of the shape have been shaded in. Now looking at this circle, my denominator, well, there are 8 equal parts, so my denominator will be 8. How many have been shaded in? Because that will tell me my numerator, 1, 2, 3. Therefore, looking at my fraction with my numerator, my vinculum and my denominator, 3/8 of the shape has been shaded in. 3/8. The third question, slightly more tricky. What is 2/3 of 9? Well, from our last two lessons, there are different ways of solving this, but I know the first step is to divide the whole of 9 by the denominator 3, and I can use the circles method here. So I know I need to share 9 equally into 3 groups, because I'm trying to find what 1/3 is to begin with. So 9 divided by 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know now, once I divide 9 by 3, 1/3 is equal to 1, 2, 3. Here's another third with 1, 2, 3, and another third with 1, 2, 3. But I don't want to know what 1/3 is. I'm trying to find 2/3. So 2/3 of 9 is 1, 2, 3, 4, 5, 6. So well done if you got those all correct. So 2/3 of 9 is equal to 6. And Mr. Wernick had 9 sweets and he ate 2/3 of them. He ate 6 sweets, or I ate 6 sweets. Really well done. Now let's start our last lesson. Well, new learning from our last lesson. The key learning today is to identify equivalent fractions. Don't worry if you have not heard the word equivalent fractions. I imagine most of you haven't, which is fine because you haven't learned it yet. So let's go on and understand what I mean by an equivalent fraction. But let's start with our key words. Equivalent, half, quarter, the same as, is equal to. Well done. Equivalent just means when a fraction is equal to another fraction, or it has the same value as another fraction. So let's have a look here. This has asked me to shade this square, to shade 1/2. So I'm going to shade 1/2 of this. There we are. I've shaded 1/2. Now the exact same shaped square has asked me to shade 2/4. When I have quarters, I have 4 equal parts, and it's asked me to shade 2 of those 4 equal parts. So That's 1/4 shaded. And now I've shaded 2/4. What do you notice about the 1/2 and the 2/4 being shaded? Pause the video and have a think. What do you notice about that? Well done. If you've noticed, actually, the same amount has been shaded of this square and this square. So what we realise is 2/4 and 1/2 are equivalent fractions. They are equivalent fractions. They have the same amount shaded. And then if I look here, if I was to transfer these 2/4 onto my half, it is a perfect fit. What that means is if Mr. Wernick ate half of a cake and Miss Head ate 2/4 of the same size cake, we've eaten the same amount because 2/4 and 1/2 are equivalent fractions. Equivalent fractions. Let me show you another way. And hopefully you can see me now. Let's imagine, okay, let's not imagine, I'll show you. This is my hole. This strip of paper is my hole. If I fold it and I create two equal parts, I've split my hole into 2 halves, because when I have halves, it's 2 equal parts. I'm now going to shade 1/2. It's a bit like Blue Peter, except I haven't got one already made. Here we go. I've now shaded 1/2 of my hole. Thumbs up if you agree that I've shaded 1/2 of my hole. Brilliant. Everyone's thumbs should be up now. I have 2 equal parts and I've shaded one of those 2 parts, 1/2. Now, year 2, I'm going to split my hole into 4 equal parts. So I've got 2, but I'm going to split it into 4 equal parts, into quarters. But I'm not going to shade anything else. I'm going to keep that half shaded. So now, year 2, I've got, and I'll do some lines to make it really clear that I've done that correctly. We can see here, I've now got 4 equal parts, but how many of those equal parts have been shaded green? 1, 2, 2/4. So we can quite clearly see here, 1/2 is the same as 2/4. 1/2 is an equivalent fraction of 2/4. 1/2 is an equivalent fraction of 2/4. They have the same value. They are equal to each other. Okay, it's really, really important we can understand that. Before, I just shaded 1/2 when I had 2 equal parts, but then I split my hole into 4 equal parts, and this half that was shaded now occupies 2/4. 1/2 is equal to 2/4. Let me see if I can show you another way of doing this. Here, I have a lovely banana. Okay, there's my banana. I can cut my banana into 2 equal parts. Okay, 2 equal parts. I have now cut my banana in half. I've cut the banana in half. But I could cut my banana into 4 equal parts. Okay, I could cut it into 4 equal parts. Now I've cut my banana into quarters. So before it was in halves, then I cut it into 4 equal parts. But let me put these back together to make 1/2. But I'm going to keep these as my 2/4. And you can see here, that the 2 quarters, if I'm bringing it over this way, 2 quarters are equal to 1/2. 2 quarters are equal to 1/2. They are equivalent fractions. They are equivalent fractions. And then we also know that my 4 quarters equals 1 whole. And there we are. My banana is all back together. Anyway, I'll eat that later. I'll turn it into a nice smoothie. Okay, so really well done. Great understanding. Hopefully some different ways of seeing and understanding that equal to 2 quarters. But let's put it into practice to prove that a little bit more. You're all doing so well. If you did have a spare strip of scrap paper, you can practice doing that, halves and quarters. Let me share my screen as we carry on. So it says here, Sophia and Casper had 8 sweets. Sophia ate 1/2 of them and Casper ate 2 quarters of them. Who ate the most? So who ate the most? So it says Sophia ate half. So I'm going to put a little S here for Sophia. I'm going to put a C here for Casper. So I wonder how many sweets Sophia ate. Well, we know she ate half. So to do that, I'm going to have 2 parts here because my denominator is 2. And I'm going to share my 8 equally. 1, 2, 3, 4, 5, 6, 7, 8. She ate 1/2. Sophia ate 4 sweets. I hope she had room for dinner. She ate 4 sweets. It says Casper ate 2 quarters of his 8. So we know he ate 2 quarters. So I'm going to have 4 parts here because his denominator is 4. So let's share his 8 sweets equally into 4 groups because each group will tell me 1 quarter. 1, 2, 3, 4, 5, 6, 7, 8. So 1 quarter is worth 2. 1, 2, 1, 2, 1, 2, 1, 2. But Casper didn't eat 1 quarter. It says Casper ate 2 quarters. So 2 quarters of 8 equals 1, 2, 3, 4. He also ate 4. So Sophia ate 1/2 of 8 and ate 4. Casper ate 2 quarters of 8 and ate 4. What does that mean? Well, it means 1/2 is equal to 2 quarters. They are equivalent fractions. I say it, you say it. Equivalent fractions. Equivalent fractions. Let's sing it. Equivalent fractions. Let's say it in a cool Batman voice. Equivalent fractions. Brilliant. All equivalent fractions mean to you two is 2 fractions that have the same value. And we showed that here. We proved 1/2 is equal to 2 quarters because Sophia ate 1/2 of 8 and ate 4. Casper ate 2 quarters of 8 and ate 4. Let's prove it one more time. Talia and Sebi had 4 sweets. Talia ate 1/2 of them. Sebi ate 2 quarters of them. Who ate the most? So Talia ate 1/2. So do a little T here to make sure we're all clear. That's Talia. And Sebi ate 2 quarters. Well, Talia, why am I telling you? You can tell me why Talia has 2 parts here. Tell me now why Talia has 2 parts here. Well done. Because Talia ate half. Her denominator is 2. And when we eat half, when we look at halves, we have 2 equal parts. So let's share Talia's 4 sweets into halves. 1, 2, 3, 4. So Talia ate 1/2. So she ate 2 sweets. It said Sebi ate 2 quarters. So we need to split Sebi's whole into 4 equal parts because that's what quarters are when you have 4 equal parts. When your denominator is 4, you have quarters and you have 4 equal parts. Let's share Sebi's 4 sweets into quarters. 1, 2, 3, 4. Each quarter is worth 1. But how many quarters did Sebi eat? Did he eat 1 quarter? Well done, everyone. No, he ate 2 quarters. So what is 2 quarters equal to? 1, 2. Sebi also ate 2 sweets. 1/2 of 4 and 2 quarters of 4 gives you the same answer of 2. Why? Because 1/2 is equal to 2 quarters. They are elephant fractions. No, not elephant fractions. They are excitable fractions. No, that wasn't. What was that word I've been telling you throughout the day? What was it? Well done, most of you there. Equivalent fractions. I say it, you say it. Equivalent fractions. Equivalent fractions. Brilliant. Absolutely fantastic. One more time. Nyan, what was it? Well done. Equivalent fractions. Got to keep you all on your toes. Here's a question. I haven't got my pause logo. I forgot to put it on. But pause your screen. It says, Yeshua swam half of the pool. Blake swam 2 quarters of the pool. Who swam further? Yeshua swam 1/2 of the pool. Blake swam 2 quarters of the pool. Please pause the video now and explain who swam further. Talk to your partners, your cuddly toy, your hand, someone working with you if they are. But pause the screen. Who swam further? Well done if you said they swam the same distance. No one swam further. They're both swimming in the same pool, and we know Yeshua swam half of the pool and Blake swam 2 quarters of the pool. I can show you this. So if Yeshua swam half of the pool, that means he swam up to the blue line. If Blake swam 2 quarters, where I split my pool into now 4 equal parts, he swam 2 quarters. Also, let's keep it black. He swam 2 quarters. Well, here's 1 quarter. And here's my 2nd quarter. He swam up to the blue line. Yeshua swam 1/2. He swam 1/2. And we can see it is the same amount. So no one swam further because 1/2 and 2 quarters are equivalent fractions. Really, really well done. Must say it one more time. 1/2 is an equivalent fraction of 2 quarters. They have the same value. So are they equivalent? Are they equivalent? Now what I'm going to do is stop sharing my screen. I want to see if 1/2 and I want to see if 4/6 are equivalent fractions. Do they have the same value? Well, to do that, I can find 1/2 of 12 and 4/6 of 12. And if I get the same amount, I know they're equivalent fractions. If I get different amounts, I know they are not equivalent fractions. So let's start by finding 1/2 of 12. 1/2 of 12. To do that, I need to do the whole, which is 12, and divide it by 2. So this is the method I'm going to be using. I'm going to do 12 divided by 2. So I'm going to share my 12 equally into 2 groups because my denominator is 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know 1/2 of 12. I want one of these halves. It is 1, 2, 3, 4, 5, 6. Okay, 6. Let's see if I get the same amount when I do 4/6 of 12. So 4/6 of 12. I'll do it in a different colour to make it really clear. 4/6 of 12. Well, again, I need to start off step 1, divide the whole by the denominator. My denominator is 6, so I'm going to have 6 groups. 1, 2, 3, 4, 5, 6. And now I need to share my 12, my whole, equally into my 6 groups. Because my denominator is 6, I have 6 equal groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. But I don't want to know what 1/6 is. 1/6 of 12 is 2. It's asked me what 4/6 of 12 is. So I need 1, 2, 3, 4, 6 of 12, which is 1, 2, 3, 4, 5, 6, 7, 8. Look, 1/2 of 12 gives me 6. 4/6 of 12 equals 8. That means 1/2 and 4/6 are not equivalent. I've just realised going through the lesson, I feel it said illant. It's an A here. Equivalent. That's Mr. Wernick's dyslexia playing up there, not realising it, but it should be equivalent. So I'm pretty sure it was I earlier, but it should be an A here, just to clarify. And that is how you answer a question. That is how you answer a question. Let me lift this up a little bit more so you can see the whole thing. And I will do one more. It's hard to get it all in. It doesn't actually go any higher than this, but hopefully it just squeezes in. Let's do one more. I would like to know if 4/8 and let's go with 2/4. I want to know if they're equivalent. I want to know. So I can check that by finding 4/8 of 8 and 2/4 of 8. If I get the same amount, it means they are equivalent fractions. Let's start by working out 4/8 of 8. So 4/8 of 8. What's my first step? Who can tell me through the computer? What's my first step going to be to work out 4/8 of 8? What do I need to do? You're right. I need to divide 8 by 8. I need 8 equal groups because that's my denominator. 1, 2, 3, 4, 5, 6, 7, 8. My denominator is 8. So step 1, divide the whole by the denominator. My denominator is 8. Now I need to share my 8 equally. 1, 2, 3, 4, 5, 6, 7, 8. Brilliant. So I know 1/8 of 8 is 1. But year 2, I don't want 1/8. I want, well done, 4/8. I want to know what 4/8 is. Well, that circle 4. 1, 2, 3, 4. 4/8 of 8 is equal to 4. 4/8 of 8 is equal to 4. Let's see if 2/4 of 8 gives me the same amount, the same answer. So 2/4 of 8, what does that equal? Well, how am I going to solve it? Step 1 when finding a fraction of a whole is divide the whole by the denominator. 8 divided by 4 is step 1. So if I'm divided by 4, I want 4 circles. And now I can share my 8 equally into 4 groups. 4 equal parts because it's quarters. Share my 8. 1, 2, 3, 4, 5, 6, 7, 8. Brilliant. So I know 1/4 of 8 is equal to 1, 2. Look, each of these is 1/4. 1, 2, 1, 2, 1, 2, 1, 2. But do I want to know what 1/4 of 8 is? No, I want to know how many quarters. What's my numerator? 2. Well done. So I'm going to circle 2 because that's 2/4. So what is 2/4 of 8? 1, 2, 3, 4. Dun, dun, dun. We have the same amount. We have the same amount. So what does that tell me about 4/8 and 2/4? What does it tell me? They are what fractions? Brilliant. Therefore, I can write 4/8 and 2/4 are ignore my error earlier, equivalent fractions. Which means if I gave Miss Baldwin 4/8 of a cake and I gave Miss Head 2/4 of a cake, I've given them the same amount of cake. There we are. That is how you're going to solve them. If you need to watch that bit again, please do. Please watch that again. So let me start sharing my screen and hopefully you can see this. I would like you now to pause the video and solve these 3 questions. Remember to write down afterwards, are the fractions equivalent or not? Please pause the video, off you go. Well done. I wonder how you did. Let's see if you got these 3 questions correct. Let's see if you got these 3 questions correct. Well, 1/4 of 8 you should have found to be 2. And if you found 2/8 of 8, it was also 2. That means 1/4 of 8 and 2/8 of 8 are equivalent. So well done if you worked that out. 2/3 of 12, if you worked out 2/3 of 12, you would have found it was 8. If you had found 4/6 of 12, you also should have found it was 8. Therefore, 2/3 and 4/6 are equivalent. Question 3, you should have found 1/2 of 16 to be 8, and you should have found 3/4 of 16 to be 12. That means 1/2 and 3/4 are not equivalent. They are not equivalent. Well done on your maths today. There were some really tough questions. I'm now going to leave you with a little riddle. And I'll tell you something. 1/2 is equivalent to 2/4. We learned that today. 1/2 is equivalent to 2/4. They're also equivalent to 3/6. And it's also equivalent to 4/8. And this is true, I'm just telling you this. And these are also equivalent to 5/10. Pause the video now. What's the pattern you see here? 1/2 is equal to 2/4, which is equal to 3/6, which is equal to 4/8, which is equal to 5/10. Can you see the pattern? If you can't, don't worry, but have a think now. Pause the video. What's the pattern you can see with these equivalent fractions? Well done if you noticed. Whenever the denominator is double the numerator, the fraction is same as 1/2. 10 is double 5. 8 is double 4. 6 is double 3. 4 is double 2. And 2 is double 1. Whenever the denominator is double the numerator, the fraction is equivalent to a half. And that's difficult. So if you don't quite grasp that, do not worry. It's that little bit of challenge, that little bit of stretch. I'll say it one more time. Whenever the denominator is double that of its numerator, the fraction is equal to 1/2. Okay. Anyway, really good work today. I will speak to you all on Monday for maths for a new topic. But you only have one more maths lesson with me next week, and then I'll be doing some writing work with you, which is very exciting. I will see you all later. Excellent work, everyone. and good. There we are, my place. See you later. Bye bye.